Good evening, everyone, and welcome to the NPTEL's fifth live interactive session on the course Engineering Metrology. The course instructor for this course are Professor J. Ram Kumar and Professor Amanding Singh Oberoi. And I am an additional TA, Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. So, in this live interactive session, we will be going to discuss some questions that are related similar that are dependent on your week course content, so which will in turn help you in solving your weekly assignment. So as this is the live interactive session, I hope for the interaction. Okay, so if you have doubt in any question, you can ask me. Okay, so we will begin. So before going directly towards the question, we will quickly recapitulate what we have studied in the week 5. Okay. So in week 5, we have studied comparator and transducer. Okay. So first we have seen the comparator. Okay. In comparator, we have seen that it is used for linear measurement, and it compares the standard with the unknown. Okay. Also, we have seen the accuracy of comparison, like what are the factors that affects the accuracy of comparison. So the accuracy of comparison is depend on accuracy of the standard is used. Okay. Okay. Secondly, the accuracy of comparison also depends on the list count of the standard. Okay. If the list count is very low for the standard, then the accuracy will comparison accuracy will be very high. Similarly, it will also depend on the sensitivity of the standard. Also, it depends on accuracy of reading scale, how accurate the reading scale of the comparator is. Okay. So, after this, after comparator, we have seen the functional requirement of comparator. Okay. So in that we have seen that the list count should be the 1/10 of the tolerance that is being measured. Okay. Similarly, it should have the high accuracy and precision. And similarly, the scale should be linear. And it should have the wide range. Okay. After that, we have seen that it should have the high amplification factor. Similarly, it should have a good resolution and provision for. It should have good resolution, and it should have the provision to compensate temperature effect. Okay. So after that, after this, we have seen the classification of comparators. Okay. Okay. So in that, we have seen first one is the mechanical. Then we have seen the mechanical plus optical. Then we have seen the electric and electronic comparator. Then we have seen the pneumatic comparator. Okay, and then we have seen the projection and multi-check comparator. Okay, so in mechanical comparator, what we have seen the dial indicator, Johansson microcator, and after that we have seen the sigma comparator, and in mechanical plus optical we have seen the Cook's optical comparator, and in electric and electronic we have seen the LVDT. Okay, and in projection based we have seen the optical projector. Okay, so these things we have seen in the our comparator section. Okay, in that the Johansson microcrater, it works on the basic principle of that Abramson movement. Okay, and it is named after H. Abramson, who invented this instrument. Okay. Okay, so after that we have seen the transducer. Okay, that is, it converts one form of energy into another. So in this we have seen the generalized measuring system. It comprises of three main stages. That is, the first one is the primary stage, or we also call it transducer stage. Okay, or primary detector also we can call it. Okay. Similarly, the second one is the intermediate modifying stage. Also, the third stage is the output or terminating stage. Okay. So after this, we have seen the transfer efficiency. Okay. So that transfer efficiency is used to compare the different devices used in first stage. Okay. This term was invented by the scientist Simpson in the year 1955. Okay. So it gives the information, that is the information sensed and delivered or delivered. Okay. So from this we can define transfer efficiency as information. Can anyone tell how we define the transfer efficiency? Okay, information delivered to the
type N.
okay, it is information sensed. Okay, so as the delivered information cannot be greater than the sensed information, as the transducer will not generate anything inside it or on its own, so the transfer efficiency, okay, cannot be greater than 1. Okay, so after this we have seen the classification of transducer. Okay, in that so what are the different types of transducer? First one is the primary and secondary. Okay, then we can also categorize it on the based on the principle of transducer transduction. Okay, okay, so based on the principle of transduction, we have 3 different transducer, that is capacitive, inductive, and third one is anyone? Hansraj, Mr. Hansraj, Mr. Vijay.
Resistive.
Okay, it's resistive. Okay. Then we have active and passive transducer. Then we have direct and indirect transducer. Okay. So, and also we have the analog and digital transducer. And the last one is null and deflection type. And after this, we have seen some terminating devices, some intermediate devices. So these all the things that has been covered in the week 5 content, okay, or in the last week content. So based on this information, we will try to solve some problems which will help you to solve your assignment. Okay. So coming to our question, the first question is, the comparators are generally used for linear measurement. Is that true or false?
It's true.
Yeah.
For me, it's true.
Yeah. Any other? Mr. Hansraj, Mr. Vijay? Okay.
Yes, sir. True, sir.
Yeah. So, yeah, Mr. Hansraj, Mr. Roderick, you are correct. The correct answer is true because in comparators, we use tolerances. Okay, we don't check the compare the basic size. Okay, we use the tolerances, and these are the linear measurements. So that's why we use the comparators. Okay. So second question is, the cathode ray oscilloscope is a voltage sensitive device that is used to measure and analyze waveform, current, voltage, resistance. Anyone?
Sir, voltage, to measure the voltage.
Okay. Any other answer? Yes. Sorry, Hansraj. The correct answer is
Sensitive to current.
it is waveform. Okay, the correct answer is waveform because that our CRO. Okay, it's voltage sensitive. Okay, it is voltage sensitive, but it is used to view and measure and analyze the waveform. Okay, so it depending on the change in voltage, we can see the waveform on the CRO. Okay, that is the cathode ray oscilloscope. So sometimes people get confused and they answer voltage. Okay, but it is the voltage sensitive device. Here you can clearly see they have mentioned it is voltage sensitive device. Okay, and that is used to measure the or measure and analyze the waveform. Is that clear? Okay.
Yes, sir. Sir, please repeat once again. Like, why not voltage?
Okay.
Like, yeah.
Yeah. So, okay. So, let me draw. So, this is your electric gun, okay? And it is highly vacuum. So here you will be having the electric gun, okay? After hitting means after applying a voltage, it will emit the electrons, okay? And that electrons will be channelized and will be projected on the screen, okay? This screen, okay? And depending on the voltage, it will give the bright or dark spots on the screen, and from that we can study the waveform. So that electron gun is operated means it is the voltage sensitive gun. That's why. So we can't measure the voltage, but we can use that voltage information to measure the waveform and analyze the waveform. Is that okay?
Yes, sir. Yes, sir. Okay, sir.
Moving to next question. Okay. What happened? Okay. There are blank functional elements for transducer or measuring system. How many functional elements are for a transducer or a measuring system?
4 elements.
How much?
Yeah, 4 elements. 4 elements.
Okay. Anyone? So, sorry, Mr. Roderick, the correct answer is there are 3 functional elements for a measuring system. First one is our primary detector. Then we have the intermediate or modifying stage. And third one is the output or terminating stage.
This one.
Yeah, it's 3. But this is for our functional element for transducer for measuring system. Okay, these are for measuring system. Okay, if we use it for feedback system, then there will be one more element that so it will become 4. But they have asked for the measuring system, so that's why there are only 3. These 3 are the measuring. These are the 3 functional elements for a transducer or any measuring system. Okay, so first we will detect that quantity using the primary detector. then we process it, and then we get it on our output or terminating stage. So these are the basic three functional elements. Okay. So moving to our next question. What is the recommended least count of an instrument having tolerance 0.1? Anyone? Mr. Hansraj, Mr. Vijay, Mr. Ram.
Sir, 0.01.
Okay. And any other answer?
0.001.
Okay. Any other answer? So can you tell Mr. Hansraj why is it 0.01?
Sir, like we are taking the tolerance variance like 0.1, like upper limit, lower limit. I think so.
So Mr. Roderick, can you tell why? And what should be the criteria for selecting the least count of instrument? Okay, so as you can see in our previous slide, so here I have shown you that functional requirement, that is least count should be 1/10 of the tolerance. Okay, so in functional requirement, we have seen the least count should be 1/10 of the tolerance, and here the tolerance is 0.1. So least count should be 0.1 divided by 10. So it comes out to be 0.01. Okay, so this should be the least count. So the correct answer is 0.01. Understood?
Yes, sir.
Thank you.
Yeah.
Thank you.
Yeah. Okay. So moving to our next question. In dial gauges, which of the following contact point is most preferred? Spherical, flat, tapered, button.
Flat. For me, flat is not perfect.
Mr. Hansraj, Mr. Vijay, Mr. Ram.
Spherical.
Okay. Yeah. Any other option?
Sorry, sir, tapered.
Okay. So
Spherical, like
spherical, okay. So we have three different answers: spherical, flat, and tapered. So we will see which one is the correct one. Okay. So suppose I am having a spherical contact. Okay. This is the contact point. This one is the spherical. And I also have one. This is the flat one, and also the fourth one is the tapered. Okay. So if I keep this on our workpiece, okay. So you can see in when we use the spherical contact point, so we get here only point contact. And when we use flat, here you can see we get a line contact. And in here also in tapered condition also we get a line contact. And in button also we get a line contact. So we should use such a contact point which gives the minimum contact. Okay, like here we can use point contact. Okay, as it is having the minimum contact, so the wear and tear will be the less. Okay, also it will not as the line contact, it can sometimes this line contact cannot be proper and we might get a error in our readings. So we prefer the point contact when we use the dial gauges. So out of this, only the spherical one will provide the point contact. So that's why in dial gauges we prefer spherical contact point. Okay, so the correct answer is spherical one. So any doubt in this one?
Clear, sir. Clear.
Yeah. Okay. Moving to our next question. Which of the following statement is true about Johansson microgreater? Amplification varies inversely with number of turns on metal strip and width of the metal strip. Amplification varies directly with the number of turns on metal strip and width of the metal strip. The more number of turns on the strip, the higher the amplification, or the amplification varies inversely with the length of the metal strip. So what do you think? Which one is the correct regarding the Johansson microgreater? Anyone? Anyone? Mr. Hansraj, Mr. Roderick, Mr. Vijay? Okay. So, in Johansson microgreater, the amplification theta by dl is directly proportional to the length and okay. So here this is the amplification formula for the Johansson microgreater. Okay, so here d theta by dl is the amplification, where L represents the length of the metal strip, W represents the width of metal strip, and N represents the number of turns. Okay. So here from this equation you can see that the amplification is directly proportional to is directly proportional to the length of metal strip and inversely proportional to the number of turns and width. So out of these four, which option is correct according to this equation? So that is the first one. The amplification varies inversely with the number of turns on metal strip and the width of metal strip. This one is correct. Okay. The amplification varies directly with number of turns on a metal strip and the width of metal strip. Okay. So this one is wrong. Similarly, the more the number of turns of the strip, the higher the amplification. Yeah. This one is. This one, the more the number of turns of the strip, the higher the amplification. This one also is wrong. The amplification varies inversely with the length of strip. This one is also wrong because it varies directly proportional. So the correct answer to this question will be the first one. Okay. Any doubt? Okay.
No.
So moving to our next question. Which of the following statement is or are true about the transducers? If a measuring device that measures and transforms a non-electrical variable into a electrical variable, it is called inverse transducer. If a measuring device that measures and transforms an electrical variable into non-electrical variable, it is called direct transducer. Or both A and B are true, or both A and B are false. Okay. Can anyone, Mr. Hansraj, Mr. Rodrigo, Mr. Vijay, Mr. Sheshgiri?
What the false?
Okay. Any other option? Any other answer? Mr. Ramlal?
Sir, both D option, both A and B are false.
Okay. And why is it so?
Because sir, the inverse transducers changes the convert the electrical quantity into non-electrical. I think the opposite is written over here.
So you have means what are you saying? Can you repeat?
Yes, sir. Sir, I am saying in the inverse transducer, the electrical quantity is converted into non-electrical quantity. The reverse is written over here in these statements.
Okay.
I think so. Yes.
Yeah. Okay. So this one is also wrong. This one is also wrong. Okay. And this one. So the correct answer is the last one. Why? In direct transducer, electrical quantity will be converted into non-electrical variable. Or am I writing it correct or not? So in direct transducer, and in indirect transducer,
So electrical quantity into the non-electrical variables.
okay. So based on the definition of direct and indirect transducer, we can easily answer this question. That is, both the options are false. So the next question is, the electrical comparators generally depend on Wheatstone bridge principle, Abbe's principle, Kelvin doubles bridge principle, none of these.
For me, it depends of Wheatstone bridge principle.
Okay. Any other answer? Okay. So the correct answer is Wheatstone bridge principle. Can anyone tell where we use Abbe's principle and what does it tell? We have already seen this in, I think, in week 3 content. Am I right, Mr. Hansraj? We have already seen what is the Abbe's principle.
Yes, sir. Yes.
Yeah. So can anyone tell what is the Abbe's principle? Okay, we can directly go to next question. Okay, but we should know
So
the.
actually, yes.
Yeah.
So I think so in Abbe's principle, like it depends upon like it related to I think so precision, like whatever the accuracy that we have. Like when we do the measurement, if the scale is in the same axis, whatever the components that accuracy we are measuring, so it will be I think so Abbe's principle.
Okay.
Yes, sir.
Okay. Yeah. Yeah, Mr. Hansraj, you are right. When the axis of our workpiece is in line with the axis of our instrument, then at that time only we will get the maximum accuracy. So that's why our in case of micrometer screw gauge, the line of axis of workpiece is in line with the axis of the instrument. That's why we get the higher accuracy as compared to that of the vernier. So that talks about the Abbe's principle. So these 3 things you should know. Okay, as if we move forward, so some options will be from your previous week content only. Okay, so I put these options because you should this should revise your concept and which will help you in your exams as well. Okay, so moving to our next question, the input resistance of VTVM is blank space when compared to simple meter, moderate, zero, very low, very high. Okay, first, before answering this question, tell me the full form of VTVM. What do you mean by VTVM? Anyone?
Sir, vacuum tube voltmeter.
Vacuum tube voltmeter. Yeah, yeah, Mr. Chandra, you are right. It's vacuum tube voltmeter. Okay, it's vacuum tube voltmeter, and it is used to measure the voltage. And as the grid circuit that is used in the vacuum tube voltmeter gives the high circuit resistance or high grid circuit resistance, the VTVM gives the very high input resistance when compared to our simple meter. Okay, this is just a simple question. Okay, moving to our next question. The null type transducer can be used for dynamic measurement. Is it true or false? Anyone? Anyone? Mr. Vijay, Mr. Chandu. Mr. Prajwal, anyone?
Yes, sir. I think so, sir. True.
Okay. Any other option? Okay, the correct answer is false. Okay, why? Because in null type instrument, we use the reference point as our zero. Like we try to bring back the deflection to the zero. Okay, but so when it comes to the dynamic measurement, so there might be a deflection. Okay, so which will not sometimes bring the null type instrument zero. Some deviations will be there, so we cannot measure accurately using the null type instrument. So that's why we, in dynamic condition, we prefer the which instrument? It's deflection type. So the correct answer is false. So moving to our next question.
Sorry, sir. The last question, sir. Like the null type transducer are like they are like more accurate, na, sir?
They are more accurate. Okay, when it comes to the static measurement. Okay, when it comes to the static measurement, means there is no fluctuation and at all. Okay, so but when there are fluctuation, suppose this is my pointer. Okay, and this is my zero position. Okay, and in null type, what will have? It will have some offset, and we'll try to bring it back to our zero position. If some fluctuations are there, it will not be the zero position. Okay, so that's why we will not get the correct measurement. But in deflection type, what will have happen? This pointer will deflect based on the input that we are being measured, or the input torque that will be exerted on the deflection. So if there are some minute changes in or fluctuations in your measurement, this will be detected by our deflecting type. But in null type, we always measure the quantity with respect to zero. That quantity will be equivalent to that much of input when our pointer comes at the exact zero position. But when there is a fluctuation, it will not be possible. Okay, so that's why we use
Yes.
deflection type instrument for dynamic measurement and null type instrument for static measurement. But when it comes to the static measurement, the null type are the more accurate one. But when it comes to the deflection, in dynamic, our deflection will be the accurate.
Yes. Okay, sir.
Okay. So the next question is, standards are included in comparators. Is that true or false?
Yes, sir. True, sir.
Okay. Any other option?
False, sir.
Okay. Yeah. Mr. Chandu, what do you think? Is it true or false?
Please, sir, it is false. False.
Okay.
Hello.
Yeah. I got it. Your answer, Mr. Rodrick.
Sir, true, sir.
Any other option? Mr. Prajwal, Mr. Sheshagiri, Mr. Sheshagiri. Okay. So the correct answer is the false one. Why? Because in comparator, we compare unknown quantity with the standard. So the standard is not included in the comparator. Okay, like in dial gauge, if we are using, so we will suppose if I want to measure whether the height of the block is 20 centimeter or not. Okay, so what will I do? I will take a standard of 20 centimeter, and accordingly I will set the dial gauge. And after that only I will keep my workpiece and I will slide it. If there is deviation, that means there are some variation. So it is not that. So it is not matching with the standard. So what we are doing, we are comparing it with the standard. Whereas in vernier and screw gauge, what will happen when we take a movable jaw and fixed jaw and we take a workpiece and we measure, we can directly see the readings on the scale, and means we are directly measuring. So it means the standards are included inside it. Okay. So in the comparators, the standards are not included. Okay. So the correct answer is the false one. Okay. So moving to our next question. What should be avoided while using a dial indicator? Sudden contact with the workpiece surface, over tightening of the contact points, side pressure, all of these.
Sir, all of these.
Okay. And why is it? Can you explain all 3 points? Why we should not? Why should we avoid all these 3 points?
Yes, sir. Like, sir, if the sudden contact will be there with the workpiece, then the point that is in the contact with the surface that can be damaged, or might be like accuracy will not be there in the measurement.
Okay.
It can be like
Okay. And over tightening of the contact points?
yes, sir. I think so, sir. Like, again, if we tight the contact point like very tightly, then even though there is a problem with the measurement, like accurate will not be there, accurate reading.
Okay. Okay. So you are right, Mr. Hansraj. The correct answer is all of these. So I think Hansraj already given the answer. So is there any need of explanation in this one? Okay. So moving to our next question. Johansson micrometer is based on the principle of gauge, Abramson movement, pressure difference, none of these.
Abramson's movement, sir.
Okay. Any other option?
Yes, sir. Abramson movement.
Okay. Yeah, it's the correct one. Okay. Abramson movement. So the Johansson micrometer is invented by the scientist named H. Abramson. So he we use string and we stretch it, and the button inside it will rotate, okay, or deflect. Based on that principle, he designed the Johansson micrometer, and so in the so what I'm saying, okay. So when we attach the strings, the deflection will move, okay. So he observed that movement and he invented the Johansson micrometer. So that's why the people call that movement as the Abramson movement, okay. So moving to our next question, the electric comparators depend upon which of the following for the measurement. The electric comparators depend upon blank space for the measurement, spring mechanism, sensing element, Wheatstone bridge, none of these. Anyone?
Sir, sensing element.
Okay, any other option?
Sir, might be Wheatstone bridge.
Yeah, the correct answer is Wheatstone bridge. Okay, so the electric comparators generally they depends on the Wheatstone bridge network. Okay, have you been seen the? I think in basic fundamental of electronics you have seen electric or fundamental of electronics or electric. You have seen this type of circuit. Okay, have you seen this type of circuit? Huh? This
Yes, sir. Yes.
network of 4 resistor is known as Wheatstone bridge. and it works on the principle of balancing of other voltage. Okay. So moving to our next question. The pneumatic comparators can be used for measuring diameter, measuring squareness, measuring parallelism, all of these. Anyone?
So measuring diameter.
Any other option? Any other option? Okay. So the numeric comparators we can use for measuring the diameter, squareness as well as parallelism. So the correct answer will be all of these. Okay, we can use different orifices and depending on the back pressure, discharge, discharge rate, we can determine its diameter. Also, we can measure its squareness, and also we can talk about its parallelism. So that's why the numeric comparators are most famous one in the our metrology things. There is a term called numeric metrology also because of this numeric comparators.
Sir, how can we measure the parallelism?
Okay. So what will happen? Suppose I have this surface, okay, and I have one surface like this. Okay, these two surfaces are not parallel. Yeah. So what I will do? I will take I will mark one position, okay, from this one, and I will take a orifice. This one is one orifice, and this one will be another orifice. So when I will give the air pressure from this side, okay, so this distance, if this distance from this one, it will not be same, okay, and if I move this one, so as it is not parallel, okay, as these two surfaces are not parallel, okay, there will be some difference in the back pressure, okay, and according to that, that difference in the, if the difference in the back pressure is same, okay, so then we can say they are parallel. But if the back pressure is different, then we can say that these are not parallel. Did you got my point, Hansraj?
Yes, sir. So
Yeah.
same as I think so squareness, we are talking about diameter. So the same operation will be there. Like if the pressure will be same, then
Yeah, like that one only. We will be using different arrangement of the orifices.
okay. So this two those two lines you have drawn not parallel. These are the surfaces of the component, or
This can be the surfaces, or also it can be the hollow section, or it can be the tapered section.
yes, sir. Yes, got it, sir. Thank you.
So, moving to our next question. In which stage of the process control system is the measurement system is used?
Feedback, sir.
Yeah, you are right, Mr. Chandu. Feedback. And why is it so? So, when we want to control any process, then we should have what are its output and what are its limit. Limit means under what limit we should keep our process. So, to keep that in mind, we should take the feedback from the output and provide to the process control. So, the measurement is involved in our feedback loop, okay, or in the feedback system of the measurement. So moving to our next question, calculate the transfer efficiency of a device which delivers the current as 4 ampere and senses the current as 5 ampere. Can anyone?
Sir, 0.80.
Okay. Yeah, you are right, Mr. Hansraj. The transfer efficiency is given by information delivered by information sensed. Okay. So here the information delivered is given as 4 ampere and information sensed that is as 5 ampere. So it comes out to be 0.8. The correct answer is 0.80. Okay. So moving to our next question. The active transducer do not need any auxiliary power source to produce the output. Is it true or false?
It's true. Sir. It is true.
True.
True. Okay. Okay. So can anyone tell, the correct answer is true. Can anyone tell what is the example of active transducer?
Thermocouple.
Thermocouple, yeah. It's the good answer, yeah. Like people generally give piezoelectric and all this type of answer. Yeah. But the thermocouple is the active transducer, okay. So moving to our next question. Which of the following transducer are of analog type? Strain gauge, shaft encoder, linear displacement transducer, all of these.
All.
Any other option?
LVDT.
So the correct answer is the strain gauge, okay. So in LVDT, we get the digital output. Okay. Like the change in voltage will be converted in terms of the displacement and that we get on the display. Similarly, in shaft encoder, we detect the pulse of light, okay. And in strain gauge, we detect the deflection of the spring, okay. Generally, if we are considering the wave balance, spring wave balance. So, if we are measuring the weight, okay, so how much strain it caused, that will be deflected on the scale. So it is the analog type. So the correct answer is strain gauge. Moving to our last question. Which of the following quality attributes should be present in a transducer? Anyone?
Static response.
Repeatability.
Okay. Any other option? Okay. So the correct answer to this question is repeatability. Okay. If it is non-linear, we can't use it for the measurement. Okay. After sometimes there will be a deviation or error in the measurement. If it only gives the static response, then we can't use for it, that transducer in a dynamic condition. Okay. So the second point. So it should produce it, and the third one is our repeatability. Okay. So it should produce the repeatable results. Okay, when we use under same condition. Okay, and there are some quality attributes for a transducer that we will see. Okay, quality attributes for transducer. So the transducers should have good repeatability. Okay. Similarly, it should also have good linearity. Okay, it should have dynamic response. Also, it should have high resolution. The one factor that affects the transducer is size. Okay, the size should be such that we can easily operate or we can easily transport. Okay, so the size is also one of the quality attributes for the transducer. So the transducer that we are using should be the robust enough to withstand the forces and to withstand the condition, to withstand the measurement condition. So it should have robustness, and also it should have the adaptability. Okay. Okay. Also, it should have good sensitivity, and it should also have stability and reliability. And it should have a good response time. So these are the these are the some quality attributes a good transducer should have. So the correct answer will be the repeatability. So with this question, we will wind up our session here itself. So if you have any doubt in this question, so you can ask. Otherwise, we can end our session here.
Sir.
Yeah.
Yes, sir. Sir, I am having the doubt in the 16 question. Not a doubt, but I want a conclusion from your side. In which stage of the process control system the measurement system used? Sir, only in feedback system.
Yeah, only in the feedback system we will use. Okay. Suppose what will happen? Suppose this is the workpiece. Okay. Okay. So I have tell the operator that I need it in 20 mm diameter of the workpiece. Okay. So initially, what I have given him the 30 mm of rod. Okay. This is 30 mm. So he fed it into the CNC. Okay. So we are considering CNC. Okay. So what will happen? The CNC will turn this round, this shaft. Okay. Let's say we don't know how much it has turned, but it has reduced its diameter. Okay. After that, the operator or lathe, just consider a simple lathe. Okay. So what will happen? So he will measure the diameter of this rod. Okay. And then he will see how much diameter has been reduced. And accordingly, he will give the depth of cut to the workpiece. Okay, so means what is that operator is getting the feedback from that or measurement. Okay, measurement, and it is providing in terms of the depth of fit to the machine, so that we can achieve our desired shaft diameter. So in this, basically we are using the measurement in the feedback system.
Yes, sir. But sir, the assembly will be possible if the measurement of the components will be there. Otherwise, how the assembly will be done?
Here you can see. Okay, after manufacturing, you will take a feedback whether that the part satisfies our limit of fits and tolerances. If it doesn't satisfy, then we will again do some operations and we will try to bring it back. Okay, if all the things are under the given tolerances and fits, so that assembly will take place. So assembly will be the final product. Okay.
Okay, sir. Like after feedback, the assembly will be done.
Yeah. So
Okay, sir.
if your product is not under the given tolerances, how can we assemble?
Yes, right, sir.
Yeah. So that's why we use feedback stage in the in process control. We use measurement in the feedback stage generally.
Yes, sir. Got it, sir. Thank you.
Yeah. So with this, we wind up our session here, and thank you for attending the session. Yeah, Mr. Rod. Yeah, let the people live. We can discuss.
I have some question concerning the